Hello, this is System Software and Compiler Lab Experiment 6 output. The concept for this experiment is single pass assembler for SLC. Initially, to know what is an assembler, it is a program that accepts as input an assembly language program and produces its machine language equivalent of, that is object code, along with the information for the loader. Okay. To know what are the advantages of coding in assembly languages, that it provides more control over handling particular hardware components, may generate smaller, more compact executable modules, and often results in faster execution. To know the work of this single pass assembler, it opens and reads the input file. If the input line has the opcode start, it does the following things. It finds if there is an operand field after start, then it initializes the LC to the operand value. Otherwise, if there is no value in the operand field, then LC is set to 0. And also it writes the input file to the intermediate file. In this step, if it does the following steps until it reaches the opcode end. It checks for the symbol table. If the symbol is not available, then if it is not available, then it enters the symbol into the symbol table along with the memory address in which it is stored. Otherwise, the error message will be displayed. If there is an opcode, it does the following conditions. If opcode is present in the op tab, then increment the LC by 3. Then start writing the location counter, opcode and operand fields of the corresponding statement to the output file along with the object code. If opcode is word, then increment the LC by 3, and if opcode is byte, then we are incrementing the LC by 1. And also, if opcode is a reserved word, then we are incrementing the LC by the integer equivalent of the opcode value into 3. And if opcode is a reserved byte, then we are incrementing the LC value by the integer equivalent of the operand value. And if there is no symbol in the operand field, in the operand address is assigned as 0 and it is assembled with the object code of the instruction. And also it writes the process line in the intermediate file along with the location counter value. And it also finds the length of the program, subtracts the starting address of the program from the LC, and closes all the files. Now let us go to our program. Initially I have imported the necessary header files over here, and after this I have created some objects using the buffer read and buffer write function, and I have specified the location of these text files, that the files which we have included in these, the 3 files which we have included. First file consists of these data, and our second file op table consists of this data, and also our third file, it consists of these data. Okay, I have mentioned the location of these files over here, and initially I am giving the value of LC as 0 and start also as 0. And in if condition, I am checking that if the line contains the word start, then I have declared a string array C over here. It does the function of line split, and also the value of C of 0. I am storing the value which is present in the position C of 0 to the variable called title. and if c dot length is equal to 3, then I'm just giving the value which is present in the location c of 2 comma 16 to the start variable, and I'm giving the value present in the start to the LC. Else if start is equals to 0, else I'm giving the start variable as 0, and LC I'm giving the value of start to the variable LC, and I'm just writing the value in the object WR over here. Else if the line meets the word comes to the word end, then I'm just declaring giving the value of LC as a result of this function, that is pass1 symbol 1 update. This function have passed these parameters for this function. We'll just see about the pass1 later, and if to go with the next condition, if I'm just writing with the object WR, I'm using the function toHexString of I'm passing the value of LC over here. We'll deal with this function later, and I'm giving the value of length as LC minus start, and assigning the value of start to the variable LC, and also I'm closing these objects BR and WR over here. Then I'm reading the value, the file information present inside the data present inside the file, that is inter.txt. And in this, if I met with the word start, then I'm printing the statement, that is H over here, and I'm doing the function, that is toSex of integer dot toHex. That is, these functions I have mentioned in the below part of my program. Okay. In the function toSex of string toSex, I'm just passing the value of string word over here, and I'm counting the length of the word, and I'm storing it in the variable called x. And if this is lesser than 6, I'm just incrementing the word, and I'm just counting the word size over here, and I'm storing it in the variable called word itself. And to go with the pass2 function, it consists of arguments like string, line, hash table OP, hash table of SYM, integer LC, and integer start. And over here, if I'm incrementing the value of LC with 3, and I'm checking whether if the opcode contains key of C of 2, then I'm again incrementing the value of LC with 3. Else if the line contains the word reserve word, then I'm incrementing the LC count with 3, and also I'm multiplying it with the value present in C of 3. Or if it contains if the line contains a reserve byte, then I'm incrementing the value of LC with the value in C of 3. Or else if it contains a word, then I'm incrementing the LC with 3. Okay. In the pass2, I'm checking that if C of 1 matches with any of the alphabets of that is from A to Z, and if the symbol is not contained in the symbol table, then I'm just adding the label over, a label in the symbol table. Or if it already exists, then I'm just printing the statement label already exists over here. And also I'm checking that if C of 1 equals word, then I'm incrementing the LC by 3. Or if it equals a reserve word, then I'm incrementing the LC with 3, and also I'm multiplying it with the value present in C of 2. If it equals an reserve byte, then I'm incrementing the LC with the value present in CF2. Over here, I'm reading the values present in the text file that is named as op table over here. And also, I'm closing the object, beer object over here. Now, let us see the output for this. We'll get the object code for the given program. Thank you.